For decades, Mars was thought to be a dead, dusty world. Dry, lifeless, finished. But now, NASA may be closer than ever to answering one of humanity's oldest and biggest questions. Are we alone in the universe? Two rovers, two completely different regions of Mars. Two discoveries that are forcing scientists to rethink everything we thought we knew about the red planet. Curiosity has uncovered the largest and most complex organic molecules ever found on Mars, the essential building blocks that on Earth are connected to living systems. Meanwhile, Perseverance drilled into an ancient riverbed and found something even more intriguing: a potential biosignature locked inside a rock that formed billions of years ago when Mars was warmer, wetter, and possibly habitable. Today, Mars looks dead. But over 3 billion years ago, Mars was a planet full of possibilities. It had flowing rivers carving valleys across its surface. It had lakes shimmering under the ancient sun. It had conditions that could support life, microbial life at the least. Curiosity's target, Jezero Crater, was once a massive lake. Layer upon layer of sedimented mudstones tell a story of water flowing, evaporating, and depositing minerals over millions of years. Perseverance's playground, Jezero Crater, was once a river delta where flowing water deposited layers of sediment rich in minerals. The perfect environment to trap and preserve evidence of life. Think about it. On Earth, river deltas are hotspots for microbial activity. Microbes leave behind traces in the sediment that can survive for millions of years. And now, on Mars, we might be seeing something similar. These ancient aquatic environments are the reason both rovers have been able to uncover chemistry that could hint at life. Let's start with Curiosity, the veteran rover that's been exploring Jezero Crater since 2012. In March 2025, NASA announced that Curiosity had detected the largest organic molecules ever seen on Mars. Molecules called decane, undecane, and dodecane. On Earth, these molecules are often fragments of fatty acids, the building blocks of cell membranes. Without fatty acids, cells, the basic units of life, couldn't exist. Why does this matter? Because finding these molecules in 3.7 billion-year-old mudstone is like finding an ancient library of organic chemistry preserved for billions of years. Clay-rich rocks like this act as nature's time capsule, trapping and preserving organics in a way that protects them from radiation and oxidation. Now, organic molecules alone don't prove life. They can form naturally in space or through chemical reactions in rocks. Meteorites, for instance, deliver complex organics to planetary surfaces all the time. But the combination of molecule size, chemical complexity, and context trapped in ancient lakebed sediment makes it more than just a random chemical reaction. It suggests that Mars had the ingredients and the right conditions to potentially support microbial life. This is the first piece of the puzzle. Over a decade after Curiosity first arrived on Mars, NASA's Perseverance Rover is navigating the rugged terrain of Jezero Crater, an ancient lake basin that once collected water from a river that flowed through a valley called Neretva Vallis. This valley, carved by water billions of years ago, funnels sediments into the crater, forming what scientists call a river delta, essentially layers of sand, silt, and clay that accumulated in a fan-shaped deposit. On Earth, river deltas are hotspots for microbial activity because the sediments are rich in nutrients and organic material. That's exactly why scientists are so interested in Jezero Crater. As Perseverance explores this ancient delta, it comes across a rock nicknamed Chayava Falls. The rock is roughly the size of a coffee table, about 1 meter long and half a meter wide, with a jagged surface that hints at a turbulent past, likely shaped by water flow and sediment deposition billions of years ago. The rover's high-tech instruments, Pixel, planetary instrument for X-ray lithochemistry, and Sherlock, scanning habitable environments in Raman and luminescence for organics and chemicals, begin analyzing the rock at microscopic scales, capable of detecting chemical and mineral compositions that human eyes could never see. What they find is extraordinary. Tiny, colorful mineral spots arranged in intricate patterns across the surface. Scientists nickname these patterns leopard spots because of their irregular but strikingly organized appearance. Each spot is only a few millimeters across, but the patterning is consistent, almost as if the rock carries a message from the distant past. Of course, science requires caution. Vivianite and greigite can also form without life. High temperatures, acidic conditions, certain chemical reactions with organic compounds. But here's the twist. The bright angel rocks show no signs of extreme heat or acidic alteration. That makes non-living explanations possible, but less likely. NASA scientists emphasize that extraordinary claims require extraordinary evidence. These findings were peer-reviewed and published in Nature, allowing scientists worldwide to examine and challenge the results. This isn't hype. This is methodical, careful science moving step by step toward one of humanity's most profound questions. Could life have existed on Mars? Now, let's connect the dots between the two rovers. Curiosity discovers complex organic molecules preserved in ancient lakebed mudstone. Perseverance finds mineral patterns consistent with microbial energy processes preserved in an ancient river delta. Two different rovers, two different locations, two types of chemical evidence. Both suggest that early Mars had the water, chemistry, and energy systems needed to support microbial life. Even more intriguing, Curiosity's findings are in some of the oldest rocks, while Perseverance's are in younger rocks. This suggests Mars could have been habitable for a longer period than previously thought, potentially millions of years longer, giving life more time to emerge. But rovers like Perseverance and Curiosity are incredible, but even they have limits. They can analyze rock chemistry, minerals, and textures with instruments that detect details invisible to the human eye. Yet they cannot conclusively prove life. The evidence we see, organic molecules, mineral patterns, and chemical reactions, is tantalizing. But confirming life requires more sensitive instruments than can be sent millions of miles to Mars. That's why Perseverance is carefully caching rock and soil samples in sealed tubes, preserving them as time capsules from a planet billions of years older than any life on Earth. These samples are destined for future missions that will return them to Earth, where scientists can analyze them with advanced tools. They'll examine isotope ratios, hunt for microscopic structures, and detect chemical signatures of metabolism. Measurements impossible on a rover, but crucial for answering humanity's oldest question. Were microbes alive on Mars? Even without final proof, the discoveries are revolutionary. Mars once had water, organic molecules, and chemical energy, all essential ingredients for life. The minerals we've found, like vivianite and greigite, forming leopard spots, hint at microbial-like chemical processes preserved in rocks for billions of years. These discoveries suggest that Mars wasn't just habitable early in its history, but potentially for much longer than we imagined. So, next time you look at the red planet, remember, beneath its rusty surface may lie clues to ancient life, preserved for billions of years. Mars isn't just a planet, it's a story, waiting for humanity to finally uncover it. So, if you enjoyed this video, make sure to like, share, and subscribe for more mind-blowing space discoveries.